Welcome to today's lesson on routers, switches, and gateways. Three essential devices that make computer networks function smoothly. Whether you're setting up a home network or managing enterprise infrastructure, understanding these devices is a fundamental part of networking knowledge. Let's begin with a question. How do computers in a network communicate effectively without all the data getting jumbled? The answer lies in the role of specific network devices that manage traffic and communication. These devices include switches, routers, and gateways. Let's first talk about the switch. A switch operates within a local area network, or LAN, and connects multiple devices like computers, printers, and servers. Its job is to ensure that data travels directly to the device it's meant for. Switches use something called MAC addresses, which are unique identifiers assigned to network interfaces. When a switch receives data, it checks the destination MAC address and sends the data only to the corresponding device, instead of broadcasting it to all devices. This makes data transfer more efficient and minimizes congestion. Now let's move on to the router. While switches manage traffic inside a network, routers connect different networks together. Your home router, for instance, connects your home network to the internet. Routers operate using IP addresses. When you request a web page, the router decides where to send that request, typically to your internet service provider, and then out to the wider internet. Unlike switches, routers understand and manage traffic between networks, and they often include additional functions like DHCP, NAT, and sometimes even firewalls. Before we continue, let's check your understanding so far. Question: what is the main difference between a switch and a router in terms of how they direct network traffic? Now let's look at the gateway. A gateway serves a different but equally important role. A gateway is used when two different networks or systems, possibly using different protocols, need to communicate. Think of it like a translator between two languages. For example, if one network uses TCP/IP and another uses a proprietary or legacy protocol, the gateway converts and forwards the data so that both sides can understand and interact with each other. This function makes gateways especially useful in large enterprise networks or systems that incorporate both modern and legacy technologies. To make things clearer, here's a brief comparison. Switches connect multiple devices within the same network using MAC addresses. Routers connect multiple networks using IP addresses. Gateways connect different systems or networks that may use different protocols and translate between them. In a small office setup, employees' computers are connected to a switch. The switch is connected to a router, which provides internet access. If the office also runs a legacy system that doesn't use modern protocols, a gateway is needed to allow communication between that legacy system and the rest of the network. Understanding these devices also helps clarify how firewalls fit in. Unlike switches, routers, and gateways, firewalls are security devices. They filter traffic and block unauthorized access, often working alongside routers and gateways to protect networks from threats. Let's now conclude this lesson with one final question to review your understanding. Why is a gateway essential when two networks using different communication protocols need to exchange data? To sum up, a switch directs data within a local network using MAC addresses. A router connects multiple networks and routes data using IP addresses. A gateway serves as a bridge between networks that use different communication protocols. By understanding the differences and roles of these three devices, you are better equipped to manage and troubleshoot network infrastructures of any size. Keep exploring and learning. Networks are the backbone of modern communication. Thank you for joining this lesson.